In this video, I will give you a brief overview of the cylindrical shell method, so I just call that shell method. Right off the bat, this shell method is based on the disc method and washers method. If you are new to the channel or you have never studied the disc and the shell method in the past, please watch the previous video to learn them first, because the shell method is based on the disc and the washers method. If you already learned the disc and the washers method, stay tuned. I will give you a brief overview on those two methods as well. So for the disc and the washers method, the dx and the dy integral, they all depend on the revolution axis. So in the first row of the table, you have horizontal revolution axis. So what is horizontal revolution axis? So for example, x-axis is y equals to 0, right? Let's say y equals to 5, y equals to 11, y equals to -8. So those are horizontal revolution axis. For both the disc and the washers method, when the revolution axis is horizontal, you use a dx integral. That means in the integrand, you are only allowed to have the variable x, no y in the integrand. On the other hand, if the revolution axis is vertical, for example, the y-axis means x equals to 0, or you can have vertical revolution axis like x equals to 5, x equals to 6, x equals to 13, x equals to -20. So they are all vertical line. So in that case, we have a dy integral. dy integral means in the integrand, you are only allowed to have the variable y, no x in the integrand. But if you look at the last column of the table, the shell method, it looks like the shell method is the opposite of the disc and washer. So for horizontal revolution axis, both the disc and the washer, they use dx, but the shell, we will be using dy. For the vertical revolution axis, the disc and washer, they use dy, the shell use dx. But why do we have to learn shell? I will talk about that next, but before I talk about why using shell, let me give you a brief overview of the disc and washers method. So allow me to go to the previous page of my notes. So I have everything written right here, and let me put everything on the same screen so you can take a screenshot really quick. So now we have everything on the same screen, so you can take a screenshot right now, so you don't need to go back and forth on the video. So couple seconds, take a screenshot right now. All right, are you done? So if you are done, you have the screenshot. Let's start from the top. So let me bring back to zoom in. So we start on top. So we have the disc on the left and the washers on the right. So what is this method? So this method, if you look at the first picture, I have a couple lines, right, and a curve. So I have a pink curve, a yellow line, and a green line, and then we have a two-dimensional area bounded by those three functions, right? So when you spin the area, the two-dimensional area, 360 degrees about the x-axis, do we agree that we are going to get a 3D object? And also, do we agree that there is no empty space in the 3D object? It is a solid 3D object with no empty space in the center, right? So this is called a disc method. This method is like a dish. The dish that you use to eat breakfast, lunch, and dinner every day. Dish. You don't want to see a hole in the middle of the dish, right? So dish is this method. There is no hole in the center. So why is this a horizontal revolution axis? Do you see that there is a spinning symbol on the x-axis? So x-axis is horizontal. So since you are using horizontal revolution axis, then we will be using a dx integral. So we will be using pi r square. What is the radius? The radius is the top curve minus the bottom curve, which is the pink curve subtract the green line. So the pink curve is y equals to some x. So those x, you will be take those x subtract y equals to 0, which is the bottom curve, and then pi r square is one circle, right? So pi r square is the area of one circle. Once you take the integral from a to b, then you have many circles stacked on top of each other, then you have a 3D object. Just picture this in your mind. You have a piece of paper in front of you. Can you do this right now? You have one piece of paper in front of you. That paper is sitting on your table. You draw a circle on that piece of paper. right? And then you use a knife, cut the circle out, throw all the rest of the stuff away. So do we agree that you have one circle on your table right now? And then can you pick up that circle, put it sideways? Don't let the circle sit on the table. Just pick it up, put it sideways. So so the top of the circle is facing your right hand. The bottom of the circle is facing your left hand. So you have one circle right now. So that is pi r squared. And then the integral from 0 to a means you have similar circle, and then you put some on the right, some on the left. We agree that now we have a 3D object. So that's why we have to take the integral. The integral means you have many circles, merge all these circles together. So you just go from 2 dimension to 3 dimension. So that's why we have to take the integral. Let's take a look at the next graph. So the next graph, we have a vertical revolution axis. So this time we have a spinning symbol on the y-axis. So vertical revolution axis is a dy integral. Then you will be using the right curve minus the left curve. Y right minus left, not left minus right. Because the right curve, look at the rectangle, the point touching the point, the side touching the right curve corresponds to a bigger x value, right? The side touching the left curve, which is the orange line, corresponds to a smaller x value. So when you find the distance between those two x value, you use big minus small, because distance cannot be negative. So you use right minus left, that is the radius. And then pi r squared is one circle. When you take the integral of that, so you stack multiple circles together. So you just go from a 2D area to a 3D volume. So that's this method. And why is this method again? So after you spin the area 360 degrees about the y-axis, you get a solid object, 3-dimensional, and there is no empty space in that object. So that's why this is this method. So let's move on to the washers method. So the washers method is the opposite of this. You have a hole or empty space in the 3D object. So let's take a look at the first one. So the first one, I have a red curve and a green curve. So this one I want to do 2 revolutions, one about y equals to j and one about y equals to k. So the j and the k, they are horizontal revolution axis. So therefore, we will be using an x integral. But the way you set up the radius is a little bit different. So look at the first integral. So the j minus outer, the first integral, you see right there, v equals to integral of a to b, pi times j minus outer square. So why j minus outer square? So first of all, the washers method, when you see the word washer, do not think about washing machine. That is not going to work. Washer has 2 definitions. The first definition is washing machine. And the second definition is a metal ring or a wedding ring, just a ring. So when you draw a ring, do we agree that there is an inner circle and an outer circle? So that is the second definition of washer. All right. So for washer, that means this time you have a circle and then you have a hole in the middle, because by the definition of washer, that metal ring has a hole in the middle. That is by the definition. It's not something that mathematicians make up for this purpose. Washer is a ring with a hole in the middle. Alright, so when you spin about y equals to j, which curve is closer to j, which curve is farther away to j? So it is clear that the green curve is closer to j, right? So, and then the red curve is farther away from j. And then when you do the outer minus inner, what is the distance between j and the red curve? You will have to use j minus the red curve. How come you don't use the red curve minus j? Because if you are looking for the distance between j and the red curve, you have to use the bigger y, which is the j, subtract the smaller y, the red curve. You always use big minus small, top minus bottom, or right minus left. Again, top minus bottom or right minus left. This case is top minus bottom. So you use j minus the outer curve, and then you have to square that because you have to square the radius. And then minus j minus the inner curve. So j subtract the inner curve. So j minus the green curve, square that, and then you have a dx. What about rotating about y equals to k. So for y equals to k, so the outer and inner will be the opposite. So when you rotate about y equals to k, the red curve will be the inner because the red curve is closer to k. So that's why you will be using the red curve, the top minus the bottom, inner minus k. And then the green curve is farther away from k, then that will be outer curve, the green curve, minus k. You have to square that because you have to square the radius. Okay, so that is the washers method. And then last but not least, we have a washer, and this time we have a vertical revolution axis, x equals to k and x equals to j. And then the area is bounded by two curves, x equals to y is a straight line, and then we have a sideways parabola, x equals to some y. Don't worry about what the function is. So first of all, we have a rotation about x equals to j, vertical, then we will be using a dy. So why do we, in the first interval, why do we use outer minus j? What is outer? The outer is the x equals to y. So x equals to y is farther away from j, and then the purple curve is closer to j. So that's why the orange is outer, the purple is inner. So you use right minus left, then you use x equals to y. You don't write the x in the integrand. That will be y minus the value of j. But the value of j is negative, so let's say j is equals to -3, then you will be having a y minus -3. Again, y minus -3. I want you to write the minus and the negative sign out. Don't write a plus, right? And then square the inner function, x equals to some y, so those y will be subtracting the j, and then you square that. What about x equals to k? So x equals to k, then that swap the outer and the inner curve. So for k, we have the orange is closer to k, and the purple is farther away from k. So for the outer curve, we will be using k subtract the purple curve. We use k minus outer, not outer minus k, because k is a bigger x value. The x value on the purple curve is smaller, so that's why you use big minus small, right minus left. So right is k, left is the purple curve, and then square that, and then you use k minus the straight line, so the inner curve, that inner curve is x equals to y. So let me put that in orange. So this is x equals to y. Of course, you don't put the x in the integrand, you put the y in the integrand, because this is a dy integral. There is no x in the integrand. All right, so that is a quick review of this and the washers method. Let's go back to shell. So for shell, now the question is, looks like in the first row, horizontal revolution axis, both this and washers, they use dx. For vertical, they are both dy, but the shell is the opposite. When the this and washers, they use dx, the shell use dy. When the this and washer use dy, the shell use dx. Why is that happening? Because the shell method takes care of a huge what if for the this and the washer. Something that the this and washer cannot do, the shell will take care of it. So the this and washer can take care most of the situation, but sometimes the this and the washer, they cannot solve the problem for you. In that case, when that happens, you have to use shell. So why using shell when the this and washers are sufficient? Because sometimes it is impossible to rewrite y equals to some x to x equals to some y. So I have a perfect example for you. I have y equals to 3x squared minus x to the third, and then I also have the graph below that. Now, the first thing is, are you able to write x equals to some y? Can you put x on one side? You don't need to waste your time. That is impossible. You want to write x, one x only, equals to a bunch of y on the other side. So you are not allowed to have x on the other side. That is impossible. Okay, so since that is impossible, let's do the graph to see what we can do without the shell. Okay, so below that, you have a red curve. The red curve is the 3x squared minus x to the third. And then we have y equals to 0. So we have a region between the red curve and the green line, and then I want to rotate this about the y-axis. So since this is a vertical revolution axis, we will be using a dy integral. I will use the washers method. So the washers method requires me to find the outer curve and the inner curve, right? So you have a revolution axis right here, and then which point is closer to the revolution axis. So do you see that there is a purple line, and then I use two dots, I label the inner and outer. There is a big problem right here. The inner curve and the outer curve, they belong to the same function. That is not going to work. It must be a different function. They belong to the same function. So that is not going to work. I can't do the Washer's method at all. So if you look at the right hand side, you see an integral, the volume, y goes from a to b. So that is y goes from 0 to the vertex of the parabola. What is that point? We don't know. So y goes from a to b, and then outer minus 0. So what is outer minus 0? So when you do outer, which is the outer curve, that point, subtract 0. 0 is the y-axis, which is x equals to 0. So for both 0 you see in the integrand, they are the y-axis. So this one is the y-axis, x equals to 0. But the outer curve, you will be taking 3x squared minus x to the third. That doesn't make sense, because when it comes to inner, you have to take y equals to 3x squared minus x to the third. This makes no sense at all, because the integral is a dy integral. You are not allowed to use x. That is a dy integral. You have to give me x in terms of y. Since you cannot do that, that means you are not able to set up the integral at all. So if you force to use the Washer's method, you are not able to set up the integral at all. So you don't even have an integral to find the volume, because everything makes no sense right here. So since you are not able to put x equals to some y, then this is totally meaningless. There is no way to move on at all. So that's why you will have to use the shell method. So for the Washer's method, you will be finding the outer radius and the inner radius. What about the shell method? What kind of radius do we have to set up? Or I should say, how do we set up the radius for the shell method? So that is a question that will be discussed in the next video. Alright, so that is the end of this video. For more detail, of course, you have to watch a couple more videos to understand the entire shell method. I will show all those to you in the future videos. So now, if you think my instruction is helpful, let me know in the comment below. Like the video, subscribe to my channel if you haven't done so, share the video for me. Appreciate your help and support. See you all in the next video for more shell method stuff. Signing out for now.